We're coming back for the second piece of the last day of the conference, TUG 2020, and with you, Martin Ruckert, that's going to talk to us about hint.
Hello, everybody. I'm here with my colleague Gudrun, and we will start with a video that is pre-recorded and contains some demo parts where I do the demonstrations. And then we have, that's about 25 minutes. And then Hello, I'm Martin Ruckert. I teach here in Munich at the University of Applied Sciences. In the following, I will present to you the current status of the HINT project, and I conclude with some open questions. Now, let's have a look at it. Here comes one of my favorite books. Well, I should apologize for the look, but the book is heavily used. I use the preface as a reference text for testing my hint viewer. And here comes the first mobile device. It's my smartphone, a Motorola Moto G 4th generation. You might observe that the title font is a bit heavy, whereas the body font looks a little light. This depends on the metafont mode that you use to generate the fonts. But of course, a smartphone is not the best device to read a book. Here comes another device. It's a Samsung Galaxy S4 with the same text. That looks better. Again, the title font is still a little heavy, whereas the body text looks better now. It's a different metafont mode used to generate that font. By the way, most of the features of the Android viewer's user interface were developed by our students under the guidance of my colleague Gudrun Socher in her course on mobile applications. Here are a few more examples. The hint viewer has a night mode. When you select from the menu the night mode, characters will show in white on a black background. You can revert to the normal mode the same way. Two simple gestures allow you to page through the hint file. You swipe to the left to page forward, and you swipe to the right to page backward. There is a zoom to 100% feature. You open the menu bar, you select from the menu the zoom to 100% option, and it immediately shows you the text as it would be in a printed book. Next, I will present a few slides on the current status, mixed with some more demonstration videos. The HINT project strives to provide an alternative to the DVI or PDF output formats for TECH. It was specifically designed for on-screen reading of documents. So it needs to be powerful and flexible enough to capture TECH's output, and it needs to be performant enough to display well on mobile devices with often very limited capabilities. HINT files are designed to be self-contained, including all resources necessary to display them, including fonts and images. Still, hint files should not be larger than a comparable PDF file. To be able to handle even very large documents was another requirement. Indeed, the hint file format is independent of TeX. There is no reason why, for instance, OpenOffice should not be able to output documents using the hint file format and thereby inheriting some of the best algorithms of TeX for formatting paragraphs and producing pages. For a detailed description of the hint file format, you could look at TUG Boat Volume 40, Number 2 from 2019, where I published a short paper on the design of the hint file format. The complete specification is published as a book. Let's look at the current state. Version 1.0 was released in March 2020. It contains the definition of the file format, an implementation of HyTeX and HyLaTeX to produce hint files from TeX sources, and 2 viewers, one for Windows and one for Android. The Windows viewer has a keyboard and mouse-oriented user interface, and it uses the older Win32 API. The Android viewer has a touch and gesture-oriented user interface and uses the more modern and more performant OpenEGL API to render graphics. Specification and programs are available at hint.userweb.mwn.de. Zooming is implemented using a 2-finger pinch gesture. Usually you scale the bitmap and re-render the page when you release the fingers. Some of my students, however, used the standard function of the TeX backend, which renders any page at any size and any resolution, to implement zooming. It's an impressive demonstration of the performance of the TeX backend, which reacts to the fingers without any delay. For the hint viewer, positions in a hint file are persistent. When I read a document, change sizes, and finally decide to terminate the hint viewer, and later reopen it, the text will show up at exactly the same size and position where I have left it. Version 1.1 is expected to come out in October this year. Unfortunately, the new format is not compatible with the version 1.0 format because I added 2 new tags, one to identify languages and one for character encodings. None of them is really necessary for displaying a hint file, but they are useful, for example, for text-to-speech conversion and automatic translation of texts. Further, the format of page templates has changed. Page templates were not yet implemented in version 1.0. The new implementations of HyTeX and HyLaTeX contain most of the extensions of EpsilonTeX, which are required to run LaTeX. Further, they use the kpath search library for opening files for a better integration with TeXlive. and the implementation is able to generate required fonts on the fly using Metafont. The Windows viewer now supports the printing of hint files. Using this feature, you can get a paper printout of your hint document that should match a printout obtained by running, for example, PDF-Tech and then printing the PDF file. Here is an example opening a LaTeX file. I select from the menu the Open Document item. I pick the file I want to open. Here I use a sample file by Leslie Lamport. It immediately shows on the screen, and I can adjust the size that I need for reading. Maybe that's a bit small. I can page forward by swiping to the left. I adjust sizes as I go, and when I adjust sizes, the top of the page will stay fixed. When it comes to fonts, both versions, the 1.0 and the 1.1 version, support PK fonts. PK fonts are supported by the Tech engine as well as by the viewers. The specification of hint files also includes TrueType fonts, OpenType fonts, and PostScript Type 1 fonts. TrueType fonts and OpenType fonts are also supported currently in the Android viewer, but not yet in the Windows viewer and the Tech engine. For more on the specific problems of fonts for on-screen reading, you could read my paper on Computer Modern Roman Fonts for eBooks, which appeared in the Tugboat Volume 27, Number 3 in 2016. When you run HyTech to generate a hint file, the fonts that are embedded depend on the Metafont mode. The Metafont modes are defined in the modes file, and I have added one for mobile and one for laptop devices, which are a little bit blacker than the normal fonts. The typical standard font is a LaserJet 4 font, which is used here as a default installation. When you run HyTech without options, you get the default installation font. Here it's the LaserJet 4 font, and we have seen it on the Moto G device. When you run HyTech, you can supply options, -M to specify a Metafont mode, and -R to specify a resolution. I'll now I generate the mode mobile, the hint file format is available as a short format, which is used by the viewer, and it can be converted into the long format using the stretch program. So to have a look at the file, we stretch the short format hint file and generate the long format hint file. Let's have a look at it. It starts with a directory, and you can see that it uses the fonts from the mobile subdirectory of the PK fonts. While we are at it, we can have a look at the definition section, which follows next. It starts out with the fonts, then come integers, definitions, dimensions, glues, hyphens, and other things. And at the end of the definition section, you find the content section. Here you see the definition of the title. When you use HyTech to generate a hint file, you can use the -m option to specify a metafont mode and a -r option to specify the resolution. If necessary, HyTech will then generate the necessary fonts. For generation of fonts, it relies on a regular TeX and Metafont installation. In this example, it's the TeX Live distribution 2019. Here you see the difference between blacker equal to 0 and blacker equal to 1.6. That is the setting that I have used for the Galaxy tablet. Now to images. The hint file format actually doesn't care about the format of images. It just embeds any file you give it. The TeX engine, however, needs to extract some basic information like sizes from images. And it currently supports bitmaps, PNG, and JPEG files. The viewers also support these 3 image file formats. However, I think there is no real advantage of bitmap files over PNG files. So bitmaps are deprecated and support for them will most likely disappear in the next version. Currently, 2 image formats are supported, JPEG and PNG. Here I show you an example, first with a PNG image. The capital A is a PNG image embedded here in the text. The next example will show you pretty much the same text, this time using a JPEG image that is similar. Now comes the final part of my talk. I explain to you some of the open questions. Language information is not necessary to display hint files, but it is useful for text-to-speech conversion or automatic translation of texts. The Internet Engineering Task Force has set a de facto standard by publishing BCP 47, a list of tags for identifying languages. When it comes to TeX, the Babel package is the de facto standard. However, it seems that there is no standard for embedding language tags in TeX sources and TeX format files. Maybe just a standardized extension of the What's It language node that now represents language information in TeX could do the job. A similar question arises when it comes to character encodings. They are not relevant for displaying a hint file, but necessary for understanding the content. The Internet Engineering Task Force has set here a standard as well. But is there a TeX standard? I have already talked about supported image formats. I think that a few formats that are supported in every implementation of HyTech and every hint viewer is better than a long list of formats that are not supported in all implementations. So my choice was to use JPEG for photographic images and PNG for synthetic images. There are good conversion programs available to produce these formats if necessary. But what is the format that should be used for scaled vector graphics? The formats that are popular in the TUG community, like encapsulated PostScript or PDF, require complicated interpreters to render them, burdening the viewer. Even SVG Tiny is not as tiny as one would hope and would increase the renderer for hint files considerably. So I asked myself, isn't there a simple way to convert scaled vector graphics to a glyph, for example PostScript type 1, since any viewer will need the corresponding interpreter for fonts anyway? Links are indispensable for navigating large documents on screen. When navigating a physical book, you use an index, a table of content, or a table of illustration, which give page numbers. With a physical book, you do not need to search sequentially for a given page number. With just a scroll bar, finding a page is less convenient. For on-screen reading, you want to have links that you can tap or click to get to the corresponding place in the document. Embedding links in the TUG output is already common practice when using PDF TUG. But I don't see a common standard of TUG primitives independent of PDF TUG to embed links in TUG sources. When the hint viewer displays a page, the viewer's backend maintains a data structure that is simply TUG's representation of the page as a nested list of nodes. Now, the viewer needs to extract information from that representation, or it wants to manipulate it. The user wants to click on a picture to enlarge it, or click on a link to navigate to the corresponding location. So the front end is given a position on the page and needs to know what picture or link is at that position. All these things need interactions between the user interface and the TUG data structure that is kept in the background. My question is, what should the API for such interactions with the document be? This might be of interest to all programs that interactively manipulate TUG documents. This is a somewhat special question. The implementation of HyTech is written as a literate program in CWeb. Now, change files relative to Donald Knuth's implementation of TUG make up a large part of that implementation. And it is unclear, at least to me, how to present change files in a readable and understandable way as literate programs. Here is an example of my current approach. It is readable and the best I could think of so far. But suggestions are certainly welcome. The last question concerns the future of the hint project. How can I make the hint project a long-term success? I'm just a researcher and there is only a limited amount of time that I can devote to software production. And this is not a long-term solution. So I am looking for partners in industry that would like to turn the hint project from an academic project into an industrial project. And this concludes my list of open questions for today. This concludes my talk. I hope it motivated you to try out HyTech and the hint viewer yourself. And of course, I would value your comments, your questions, your answers to my questions. Thank you.
Thank you, Martin. Can I start with the questions?
Sure.
I guess the first one I have is,
there is one on the question and answers that asked, does hint work with hyperref? Hint at the moment doesn't support links, not external, not internal, and it doesn't support colors. So you can use the hyperref package, and whatever would end up from a hyperref in a DVI file would probably also end up in a hint file. And so you could see the link as it would be on a printed piece of paper, but you cannot click on it because the clicking is not, the link feature is not implemented. That's not part of the HyTech engine. That's part of the hint viewer. And well, in the long term, of course, it should support references to other books, to resources on the internet and so on, but in the moment not. It's still open. A plan for a viewer for e-ink readers. Yes, that's what I started with. I started the whole project when I published the mix supplement to the Art of Computer program together with Don. He helped me a lot. And then the publisher asked for an ebook version. And I thought, well, I gave them a good PDF anyway, so they should make it into some format that can be displayed on an e-reader. But the result was horrible. And it took me about half a year to get out the biggest flaws of the ebook version. And I was so dissatisfied with how the book looked on an ebook reader, on a Kindle actually, that I decided I should do something about it. And that's when I started the hint project. Both viewers that we have in the moment, that on Windows and that viewer on Android, both rest on the same backend. There is a backend in C that basically reads the hint file and produces a representation, renders a page as a data structure. And then there is an API for the viewer where you can say, okay, now page forward, or I want to have a page with 215 dots per inch and 3 inches wide and 2 inches high. And then you get that data structure and you can render it basically like a DVI viewer also does it. You traverse that structure and the front end gets told where to place which character at what position. Well, that's the front end. There are interactions between front end and back end, for instance, paging or zooming. And if you start with links, you have further interactions. But it's an ongoing project and it's not yet finished. And writing a viewer for an e-ink reader is probably possible. If it's possible to use Android and Windows with the same backend, then an e-reader should not be really a further problem. Not a problem that can't be solved. That's my...
Most of them are Android based anyway.
Yeah. There is some Unix under the hood.
Can I contribute something related to an industrial partner?
Once again, please.
Can I contribute something relating to finding an industrial partner?
Oh, you're welcome.
Thank you. I'm afraid it's not good news. publishers generally don't have technical skills, and they look for suppliers to provide the stuff. But suppliers, how do I put it? They've got a different business. So publishers might be interested in innovation, but they're working with suppliers. And this is true even with one company. I used to work for an academic publisher that had a print house and a publishing house. And they had conflicting interests. And the phrase they used was our best customer for the people across the road. So that was some time ago, but the nature of the economic relations and social relations in the industry might make it hard to get an industrial partner in a conventional sort of way, because you're not selling a database, you're selling something that's got a front end. And perhaps if you could establish some sort of market with perhaps authors or publishers, that might enable you to provide a market for the software developer. That's the problem, is you want a market for the software developer without there being the software, the software developer wants a market to exist. I think that's the problem I think I'm coming up with. I've stopped now, I've explained my experience.
Thank you.
A usual question. Since you now have very maturely released, are there plans to put at least some of it, for example, the processing part or part of the viewer on C10 and eventually to distribution like Tech Live, MIGTech, MacTech, and so on? It would really help people to play with your system and contribute.
I have the yet unpublished goal of having some version of Hint in Tech Live 21.
Fantastic.
But it will still have limitations by then. But probably enough to do experiments and get something out of it. Yeah. But Tech Live is basically the only business model that we have, because there are lots of people that use Tech Live to produce documents. And the idea is, if it is just as easy as running PDF Tech or C-Tech or, well, high-tech on the same document, and you get two different output formats, then it's not really an overhead for the document producer. And it's easy for them to produce a PDF, send it to a printer, or publish it on the web, and have a Hint document without any extra effort. And then you have a Hint viewer, and you can read it on your tablet without extra effort for the author. And that might be, one way of getting the Hint viewer to be used on a broader base, not just a few eccentrics that use such a strange format. So that's definitely the aim.
Martin.
Yeah.
I see that you use PK fonts for the demonstration for scaling.
Yeah.
And I would hope, and I expect that you're playing with the blackness as the scaling is probably happening. How does it work under OpenType? How does it?
The blackness in the the Hint format embeds font files, and when you render a Hint file, so in the renderer, you need the front end gets the information that you need a certain character at a certain position on your screen in a certain size. And at that point, you get back to the font resource that is somewhere in the file. And depending on how that font resource looks like, whether it's a TrueType font or a PK font, you generate a bitmap, and then you render that bitmap on the screen. Now with a PK font, you have to fix the resolution when you generate the PK font. That's different from outline fonts. PK fonts are the only thing that are in the moment supported with a TUG backend. One reason is that I'm doing research, and being able to render PK fonts is okay as a proof of concept, and rendering a true type font means that I have to use the free type library and bind it to the renderer, and then the renderer can do that. So it's not really a research project, it's a software engineering project. And when it's not a research project, but a software engineering project, I think, okay, we postpone that for later. We get it going and show what can be done, but we don't do it yet. And so, for instance, you can, I had made sample files with true type fonts. I did that by running TUG, producing a file that had an embedded PK font. Then I converted that short format into a long format, so you have basically a text, and then I replaced the name of that file, which was a PK font, with another name of a file that was a true type font, and made the short format again. And then I started the viewer with that file, and it would have the true type font embedded. And then the viewer gets the same information. Please display a uppercase A at position this and that in this size. And then the viewer says, okay, where is the font? Here is the font. What kind of font is it? It's a true type font. I know how to render a true type A at that position, and does it. So the kind of font and the resolution of the font that is embedded is only a problem for the viewer, basically, because TUG needs only the TUG font metrics. And then you embed, you have that information at the very end, what kind of fonts are used in that document, and then you generate them and embed some font file that is able to produce the bitmaps in the viewer. But it's only a question of using, let's say, free type library and rendering characters.
Interesting.
There is a question, might it be possible to export some of this so that the resulting document can be viewed in a web browser? Well, the hint project took TUG and split it basically in the middle. There is one part, and that's basically the front end, where everything runs in iTech, and in the back end are still some parts of TUG. For instance, there is the processing of a paragraph. Splitting a paragraph into lines is one of the important algorithms in TUG, and that's done in the viewer. So the hint viewer will produce exactly the same paragraph layout as TUG would produce, because it's the same algorithm. It's just running a little bit later. When the viewer is active, you know how big your page is, what is H size and what is V size and so on. And then you can break lines, paragraphs into lines. So you have to postpone that. And that's an algorithm that is originally from TUG and that is now running in the viewer, but it's not running in a web browser. I mean, the processing of a paragraph also does the hyphenation. TUG has a 3-pass algorithm on paragraphs, running 3 times over the paragraph, and only in the second pass it attempts hyphenation. Now, HiTech runs hyphenation on every word and it inserts in every word any possible hyphenation point, because you want to do a hyphenation early in the HiTech part and not in the viewer. In the viewer, you have all these discretionary hyphens in the words, everything. And then you can break the paragraphs, but the viewer still does 3 passes as TeX does. So it tries in a first pass to render the paragraph without hyphenation, even if all the hyphenation points are there. And in a second pass, it tries to use the hyphenation. Because only through that 2-pass algorithm, you get exactly the same line breaks as TeX would do. Well, the aim was producing a TeX document with PDF TeX and producing a TeX document with hint should give exactly the same line layout. So the hyphenations are at exactly the same place and the lines have exactly the same length. So you need that algorithm to display a hint file. And that algorithm is not present in a web browser. And that is also one of the problems with HTML, that usually the hyphenation algorithms are not very good. For instance, if you have formulas inside your text, then the line breaking of formulas is not just at any possible glue as it is in regular text, but you need to insert penalties in your formula that allow line breaking, and the penalties specify the cost of breaking at exact that position. And the line breaking algorithm optimizes the whole paragraph, minimizing the penalties. And that's the way how you get good line breaks in mathematical formulas. And that's a complicated algorithm, and it's not available in a web browser. So
what we could consider actually in using is WebGL. Because I mean, for the Android version, we are now using OpenGL, and we could maybe as like a future student project look into working with WebGL. So it's
but then good idea. But then you would need to take the TeX algorithms and rewrite them in JavaScript, for instance.
Can I come?
Everything, but well, I guess.
Can I come in on this? There's something called WebAssembly, which is 50% of the speed of C code. It's sort of written in JavaScript but compiled down to native code. And using that, people have taken the WebC sources, the web sources of TeX, translated them using mscriptum, and you can run TeX in the browser through WebAssembly. And the performance is horrible, but it works. So you wouldn't have to write your own implementation necessarily. And related to this is a question that I wanted to ask, which relates to the architecture or the role. My understanding of hint is that if you take a hint file, you can produce from it a TeX source file that is very, very low level. It really basically only uses primitive commands. And then when you feed that file into TeX, and it produces output through the output routine and the paragraph breaking and everything, you'll get the same output from TeX as you get from hint, because from hint you get the same output as you do from TeX. So instead of having hint follow TeX, you could have TeX follow hint. And in that case, you could use an existing implementation of TeX in the browser using mscriptum, and you're only using one tiny bit of it, which is the output routine and the paragraph breaking. And you could get a proof of concept without having to do that much programming. And then you can see whether it's worth doing in terms of improving the performance. So there's two things. The one is you can use mscriptum and put the thing into the browser, put TeX into the browser. And the other thing is you can, so to speak, reverse the flow from TeX to hint and take it from hint to TeX and round trip. A lot of the time that makes TeX in the browser slow is loading things up and doing the paths, loading files, finding files, all that sort of stuff, loading the format. Whereas if all you're doing is running the paragraph breaking and output routine, it's a considerably smaller and I think quicker piece of work. So it might be an interesting experiment, and at least it gives you a more encouraging answer to the people that want to put hint into a web browser. I'm happy to provide technical advice about this insofar as I can. I'm going to stop now.
Seems like an interesting project, but it's not my project. I'm busy enough with getting, for instance, links into the existing system, or making the integration with Tech Live. That's the project that I have for the next half year or next year. So, and I always have to think what is distracting for me and what is the things that I have really to do.
You have one more question from Frank. If you could take that, and we delay Marcel just like a couple minutes.
Yes,
it's fine, I have time.
Frank asks, does it mean you keep track of the value of pre-tolerance and move it into the hint format? Yes, of course. You can specify and change pre-tolerance and tolerance and emergency stretch and all that, and it's in the hint file. And these
okay, so you keep track of, you keep track of all these parameters and pass them through to be able to get the same output. Yeah. My question on this point was, is it really necessary to have 100% conversion when the main goal of the hint is that you are able to reflow, basically? In some sense, most of the time, the document will not be 100% the same anyway. If you want to have a printed version, you can start from the file that you started generating the hint to. Would be my idea of keeping things simple, because otherwise you have to have these things like pre-tolerance whatsoever being passed all the time exactly into the hint format.
Yeah, I do that. And it's not a performance problem. I mean, the performance is excellent, and it's even simpler.
Yeah, it was visible.
No. These algorithms are taken from Tech with a change file, and the change file gets shorter if I don't change too much. So if I leave the pre-tolerance in, I don't have to change the algorithm, and that's the easiest and simplest thing, to leave the paragraph breaking algorithm basically as it is. So I change as little as possible.
I would have one more question if I'm allowed to, Paulo. Otherwise,
I don't want to. Sure, go ahead.
What you said, you added language, and you asked yourself about the question on how to make links work and whether they are supported on the low level. In some sense, it sounds to me a little bit as if it would be maybe helpful if you think of the hint format as having two trees, similar to the way, say, PDF adds tagged information in the PDF. And then you can extend it in some sense by having on the second tree all these kind of additional information that link between your data structure that is for the textual part and your structural information that gets all this kind of information into linked from this second tree into the other one. If that would be there, then something like, well, anything around, for example, accessibility, use of it in other aspects would be more or less automatically come with your hint format as well. And the transition, say, from something like, if LaTeX is able to produce structural PDF, it could, by the same backend, just with a change of the backend way to write, produce the hint file information in the form that hint would expect it. Just a thought. I mean,
yeah, no, it's a good idea. I try to collect the information for the hint file as late as possible from the Tech process. So whatever Tech does to its input doesn't play a role for the hint file. All that is, when the information flows into the contribution list, that's the point where I pick it up. So the whole pre-processing that makes basically the difference between Tech and LaTeX, it has disappeared, except that there are primitives that LaTeX is using that are not specified in Don's tech. These primitives must exist. But these primitives usually don't generate new nodes. They just generate the usual data structures that are stored somewhere in mem. Some of these data structures, however, are PDF specific. So these PDF specials or PostScript specials where you embed some piece of PostScript code to rotate a word. That's basically PostScript code that is embedded in your tech sources. And I don't like to have to parse PDF specials to find out what they
Absolutely
mean.
not. Absolutely not. And I mean, this is the reason why, at least from the LaTeX side, we are providing, if you like, a wrapper to this. I mean, if you in LaTeX say something like include graphics, then on the LaTeX side, it doesn't tell you whether it has to put in some PostScript special in or some PDF special or some other final device mechanism. So that is all handled by the backend. So if you have an expectation of some, basically everything for hint could be done by defining a set of specials that sits in the contribution list, and all that is needed from LaTeX side would be to provide that instead of the PostScript specials if you run hint. If you see that would be a single point of getting either to PDF or to PostScript or to something else to hint.
I will get back to you in fall when I start getting the graphics with the X package to run under hint.
We can meet on the next birthday of Don or something, or maybe earlier.
That's in January.
Yeah.
When the next semester start, I will do the graphics package.
Okay,
it's one
cool.
of my plans, and then I will ask lots of questions to you.
Well, we live in the same country, right?
Yeah.
Okay.
Same time zone.
Well, thanks very, very much for a beautiful talk, Martin. And thanks, Gudrun, as well. We'll hope to see you soon in better forms, better formats.
What do you mean? The formats are not nice? It's a nice picture of Martin with the background of Don's books. I can see 4 at least.
Yeah, no, hint is a beautiful format, and be able to handle it is amazingly good, like Gudrun said.
Okay, I think we are over our time allocated, and Marcel is already waiting.
Yes.